What's up everyone, Patrick here, welcome back. Moving on to the next word problem dealing with trigonometry. So a person on the ground spots two planes that are flying at the same altitude. One of the planes is 11.8 kilometers away at an angle of elevation of 24 degrees. The other plane is 14.2 kilometers away. And so with that scenario, two questions. Part A, how far apart are the planes? Part B, what is their altitude? So as usual, let's start with a diagram of the situation. So let's say that this here is the ground. So let's say that the person is right here and they are spotting two planes. Let's say one of the planes is here and then the other plane is right here, like that. Okay, and they're saying that one of the planes is 11.8 kilometers away. So let's say that this plane here is 11.8 kilometers away from the person, and it's at an angle of elevation, meaning this angle over here is 24 degrees, like that. Right? An angle of elevation is always from a horizontal. In this particular case, the horizontal represents the ground that the person is standing on. So the angle of elevation there is 24 degrees, and then we're told that the other plane, which is here, is 14.2 kilometers away. So if we draw a straight line like that, let's say this is 14.2 kilometers, like that. And so what we got to do is find out how far apart are the planes, right? They're at the same altitude. So basically this line and this line are going to be the same. We're actually going to be solving for that length in part B, but for now we're just finding how far apart are the planes. So we'll call this X. That's what we are solving for right there. Question is, how can we do that? Well, there's actually multiple ways you can do this. Personally, what I'm going to use is the sine law. So let me actually erase this just to give myself a little bit of more room here for any algebra we're going to do. Now, notice we got this triangle here. We have two of the sides. We're solving for the third side. Notice that right now within the triangle we don't have any of the angles, but if you notice, if we use the Z pattern, notice that because the planes are flying at the same altitude, this line is parallel to the ground. And because it's parallel to the ground, well, we could use the Z pattern, meaning that this angle and then this angle are the exact same thing. So this angle here is 24 degrees, right? Whenever you got two parallel lines, basically this angle and this angle are going to be the same. And then also this angle and this angle are the same, right? Because they're flying at the same altitude, this line and the ground are parallel, so we know that that's 24 degrees. And so from there, we now have more information in this triangle. Now, we can't directly solve for this side yet using the sine law because we need this angle over here. Let's call it theta, right? We would have to do sine theta over x would equal sine of 24 over 14.2, right? And then we would have two variables, so we can't do that yet. But notice that because we have this side, which is 11.8, we can actually solve for this angle. Let's call it alpha. So we could first solve for this angle alpha by doing sine of alpha over 11.8 over the opposite side is equal to sine of 24 over the opposite side to that 24 degree angle, which is the 14.2. And now notice that we would have an equation with only one variable to solve for this alpha angle. And then once we have that angle, very easy to find the theta angle. It would just be 180 minus those two angles. And then once we have that angle, we could set up another sine law ratio to solve for that distance between the two planes, which would be the x value. So let's first solve for this alpha. So first we would cross multiply. So 14.2 times sine of alpha equals 11.8 times sine of 24, like this. Then we could divide both sides by 14.2. We're trying to get this sine of alpha on its own. So basically we would have sine of alpha is equal to this, and then if we want to get the alpha on its own, we would do sine inverse of this entire ratio. So we'll do 11.8 times sine of 24 over 14.2, like that. And when you do that calculation, what you would end up with is the alpha angle being 19.75 degrees approximately. Okay, so that's this angle right here that we just solved for. So this is 19.75 degrees, this angle right here. Well, now notice we got two angles, so we could solve for that third angle, right? The theta is, let's actually write it down here. So the theta is just going to be 180 degrees minus the 19.75 minus the 24, which would give us 136.25 degrees, like that. Okay, and because it's 136 on the diagram, this is not to scale this angle here. It should be a little bit wider, right? So this side should be a little bit longer in order to get this obtuse angle, but you can adjust the diagram on your side. I'm just going to leave it like that, right? Because this angle in the diagram does look like an acute angle, like it's within 90 degrees, but it's actually an obtuse angle, so this should be more wide of a diagram. Okay, but let's just leave it like that. So we got the theta right here. Well, now we can set up the sine ratio again. We can do sine of that 136.25, that theta angle, over the opposite side x, which is what we're solving for. And then for the other ratio, we actually have two options. We can do sine of 24 over 14.2, or sine of 19.75 over 11.8. It doesn't really matter which one you use. You'll get the same answer. I always recommend using what you're given in the question. So I'm going to use that sine of 24 over 14.2 again. But again, it doesn't matter. You could use the other one as well. We did round this angle a little bit, right, which is going to affect the final answer a little bit, but no matter which way you use, when you solve for that x value, it should be fairly close, whichever method you use. So from here, we can, again, cross multiply. We'll have sine of 24, x times sine of 24, then we'll have 14.2 times sine of 136.25, like that. And then what we would do is we would divide both sides by sine of 24 in order to get that x value by itself. And when you do that calculation, you would get approximately 24 kilometers. I'm going to round it to the nearest kilometer. I think it's like 24.14 that you would get, all rounded to the nearest kilometer. So that's the answer for part A. Basically, the distance between these planes here is 24 kilometers, like that. Right, so that's part A. Now, what about part B? Well, part B is actually going to be super easy. The planes are flying at the same altitude. So what we can do is we can, let me just erase this to kind of give myself a little room to draw this altitude. We can draw a line like that, right here, which this is going to be 90 degrees, right? Because this is straight down, right? This altitude line, let's call it H for the height, is going to be perpendicular to the ground, like that. And actually notice that we have enough information, we had enough information before we even solved for this 24 to solve for the height, because we could create this right triangle here, and we have this angle, and we have the length of the hypotenuse. You can also create it here if you want, but remember this, this 19.75, which is using the Z pattern, that's right here, we had to solve for that first. So we could use this angle, this hypotenuse, and solve for that side. But again, I prefer to use this because we were already given the 24 degrees and the 11.8. But you could use either of these triangles. So if I draw the triangle that we're going to use, that's this one right here. We're solving for the h value. The hypotenuse is 11.8, and then we got this angle of 24 degrees like that. But again, you could also create a triangle here and you could solve for the h there. So if we use that triangle, if I draw that, this would be the h value here. We would have 19.75 degrees, and then we got the 14.2 kilometer hypotenuse. And again, no matter which one you solve with, the h value should be the same. Again, there might be slight differences in the final answer because of the rounding that we did when finding this angle, the 19.75, but you should get something very close. I'm going to use this triangle though. So if we're referencing this angle, remember the angle that is across the 90 degrees, this is the hypotenuse, and then the, sorry, not the angle that's across the 90 degrees, the side that's across the 90 degrees is the hypotenuse, and then the side that's across the reference angle, the angle you're referencing, is the opposite. That means this side here would be the adjacent. We're not going to be using that in this case though. This is a right triangle, so which primary ratio deals with opposite and hypotenuse? The sine ratio. So we can go sine of 24 is equal to the opposite, which is the h value, over the hypotenuse, which is the 11.8. And then from here, we can cross multiply. H times 1 is h, and then we'll have 11.8 times sine of 24, which would give us approximately 4.8 kilometers. And so that ends up being the final answer for part B. Right, so for part A, I use the sine law to solve for the distance between the planes, and then for part B, I use just primary trig ratios for right angled triangles to solve for the altitude.